Right, so here is the idea. What I want to look at is this idea of what is the relationship between perpendicular gradients. Now you're happy, perpendicular just means like that, at 90 degrees to. Okay, so at 90 degrees to each other. Okay, so what I've got here are 2 points, O and A. I'm going to join them together to make a line segment. Okay, now let's just suppose that A has coordinates PQ. Okay, now what I can do is I can think about this as a triangle. Okay, so if I think about this as a right angled triangle, just like we were doing before with our midpoints and our gradients and our distances, what would that distance there be? What would that distance from here to here be? It'll be P, right, because it's P across. What would that distance there be? Q, because it's Q up. Now you're happy that's exactly the same as what I've got on the screen. Okay? So what I'm going to do is rotate this shape through 90 degrees. I'm going to rotate it through 90 degrees. So if I do that, rotate it through 90 degrees, okay, are you happy it will end up over here? So let me do it in a different colour. You're happy it will end up with something like this, okay? And this is now my point. So this is still P, and this is still Q. So this is still P, and this is still Q. It's just I've rotated it through 90 degrees. Can you see that? In fact, I can do that on the screen, like so. Make sense? Okay, good. So this is my new point. My question is, what is my new point? What is my new point over here? So let's call this B. What's this new point over here? How many have I moved across by? Negative Q, right? I've moved that distance to the left. Yeah, and what's my Y? P, okay. So my question is, what are the gradients of these two line segments? So what's the gradient of OA? It's going to be change in Y, which is Q, divided by my change in X, which is P, right? Now, what's my gradient of OB? What's the gradient of this one? You sure about that? Yep, negative. So it's going to be P divided by negative Q, right? So my change in Y, which is P, divided by my change in X, which is negative Q, okay? So you're happy these two lines are perpendicular to each other. What's the relationship? Excellent. So if I multiply them together, I get -1. Do you see that? Because if I multiply that by that, the Q and the Q cancels, the P and the P cancels, and I'm just left with a negative, okay? -1. But also just look at this, because it's slightly easier sometimes just to look at the form. Are you happy that the Q and the P have swapped places? They've literally gone like that, okay? So they must be reciprocals of each other, okay? And are you happy one is positive and one is negative? So I can just say they are negative reciprocals. So in other words, if I wanted to write this formally, gradients of perpendicular lines, I'm going to use that symbol for perpendicular, have negative reciprocal gradients. Do you see that? So in other words, if the gradient of a line was 3, what would the gradient of a line perpendicular to it be? So it's going to be negative, and then I've got to flip the 3 upside down. Think of this as 3 over 1, 1 over 3. Okay, if a gradient of a line was 7, what would the gradient of a line perpendicular to it be? -1 over 7. If a gradient of a line was 3/4, what would the gradient of the line perpendicular to it be? 4 over 3. If the gradient of a line was 7 over 2, what would the gradient of the line perpendicular to it be? -2 over 7. Is that okay? Yeah, so if we're dealing with gradients of perpendicular lines, just think they're negative reciprocals.